think that's just it. You just have to accept that it's going to be a bit rough
Yeah.
but then, it gets easier.
Welcome to the LabVIEW Experiment. I am your host, Sam Taggart from SAS Workshops. In my 15 years of working with and training developers, I've had the opportunity to conduct a lot of experiments. Over here, we believe in embracing failure as the essential learning experience that it is. And what better way to learn than from other people's mistakes? In this podcast, I talk to industry experts, colleagues, and friends about their failures and how they have turned them into future successes. I'm here today with John Medland, one of the original LabVIEW Experiment fans. I think he's one of the people on the Patreon who's been there the longest. So quick little plug for the Patreon if you want to come join us. For there, we have a few interesting discussions. John, you may know he's presented several times at GDevCon over in Europe. I remember a presentation on C or C++ in LabVIEW or something. Does that sound about right?
Yeah. I also did that might have been a GLA talk, I think.
Maybe GLA.
Yeah.
I recognize you as one of the people who has, I don't know, I think of you as more of a computer science type person, just because I think you know a little bit more about like low level stuff like C, C++, and things like that. I don't know. Is that accurate?
Maybe. I mean, I like my first introduction to programming really was on like C embedded targets because I did a electrical engineering degree. So yeah, maybe that frames some of it. Or I kind of like I'll just find myself going down a rabbit hole, and before you know it, you're doing low level system stuff that you never really intended to, just because you wanted some high level thing to work in a slightly different way. So but if that's how you see me, that's cool.
Well, I feel like most LabVIEW programmers don't have that CS background and don't understand the low level stuff. There are a handful that do, that talk about like pointers and DLLs and all that stuff, but I feel like the average LabVIEW programmer probably not as much.
Yeah, I guess, and like I if you wouldn't have to, why would you dive into that side? You've got LabVIEW. It runs fast at doing lots of things. It's a nice way of representing how your application works. It's like I didn't choose to get into this, but just that's the way I could achieve what I wanted. And then it, like, in a way, it reveals something about how LabVIEW works under the hood. I think, is it like Darren Nashjet always recommends people yearly read the that document from NI, like how LabVIEW works under the hood.
Compiler,
And if you play with some of the like memory management libraries in C that are sort of provided by NI to let you interact with LabVIEW, you also get some appreciation of how memory is being managed behind the scenes. And that then can help inform choices that you make if you're dealing with like big data sets and stuff, or trying to get squeeze bits of performance out of LabVIEW. You can sort of see, why, like, I'm not using that array, but why is my memory usage still so high? Well, because it'll just sit around until something else needs it. So LabVIEW's got this whole managed memory and scheduling ecosystem on top of the low level stuff, which is great. But sometimes it's handy to know what's going on underneath to understand how you can squeeze it for every bit of performance you can get.
Yeah, that's one of those things where I feel like it's often not important, but when it is important, it's really important, because like you're trying to do some goal and it's just not working for whatever reason.
Absolutely. And it's always you don't want to pre-optimize stuff, right? So you don't want to think, well, I just want to do this quite straightforward program, but I'm gonna try and do this in as low level as possible. You want to try and solve it, and then at a certain point you're like, oh, it's just it needs to be more responsive, so we have to take a look at this bit and make it a bit more difficult. If you're bringing in like that C and C++ ecosystem into LabVIEW, you've got a whole new set of like skills that you need, and also tooling around compiling code, building it, and then trying to integrate it in LabVIEW. And it can bring other challenges with, like, LabVIEW is great. It works cross-platform for lots of things just out of the box. And as soon as you're building your own code, like shared libraries, you've got to think about the platform you're running on, and you've got to think about how you're going to bundle that up with in your executable or whatever, however you're distributing your code. And then one of the libraries I wrote, I was really keen to get running on NIRT targets. So then I had to look at like how you can sort of create a package and do all that stuff. So that was kind of fun. But there's still so much more that I want to like dive into. But got
For
to.
creating packages, are you talking about like O package or like the Linux package manager?
Yeah. This is using the open embedded package format, which is what the NIRT installs. When you SSH in and sudo
Yeah.
install stuff. Yeah. So creating those, was interesting, especially because NI provides some sort of build tools for these things, but most modern libraries for Linux will assume that you've got a much more modern tool set. So you sort of find yourself maybe building other components in this big chain to try and finally get a binary that will run in an RT environment. So that was that was like another rabbit hole where I thought, wouldn't it be good if this happens? And then you just end up learning lots more about Linux and the NIRT ecosystem and stuff. So yeah, that was fun.
Yeah. Cyril went down that rabbit hole recently trying to get WireGuard, I think, to work on our Linux RT.
Yeah, I saw a bit of that. I think I was able to sort of like I saw him doing it and was like, oh, but this might be some initial pointers, and then I think that maybe that helped. I don't know, but then he sort of came back. Yeah, like as I found like weeks later when you're like, yeah, it's a lot more involved than I had hoped, but now I've done something that's kind of cool. So yeah.
Yeah, I think I naively chimed in like, oh yeah, it runs on Linux. It shouldn't be that hard. And like, no, it's not. Like, apparently RT Linux is not like, if it runs on Ubuntu, that does not mean it will run on RT Linux.
Yeah. I've the like the I think it's one of the things that NI really could do better at providing some documentation for that sort of stuff. So I think they've got better at like how you could build code for a NI real-time target like C and C++ code, and they've even got instructions on like setting up your text IDE to like debug on a remote target, which is kind of cool. But yeah, when it comes to like if the thing you're trying to build depends on some other package or code that would be kind of an easy install in like a normal desktop Linux environment, something more modern, that's when things can get a bit dicey. And you maybe have to like I've not looked into it, but there's the whole layer of open embedded, which is and like Yocto project stuff, which is the sort of ecosystem that is used to build NIRT, the image. I mean, then you could in theory build it from source, but NI adds their own secret source when they're producing a build that includes all their drivers and stuff. So you can get somewhere with it, but yeah, that makes the sort of some of the build systems that I've used look like pieces of cake. They're like a tiny part in a huge suite of tools that can interactively build and manage and patch everything as you go. It's quite a thing, and I'm really tempted, but I'm trying to finish other projects that I'm working on in the background. So that's not just yet, but maybe one day I'll get around to it, and then I'll do a GDev talk on it or something.
Yeah, I feel like using LabVIEW in general insulates you from a lot of build problems because like it just kind of generally works until you try to get into doing CI/CD and automating all of it, and then it's its own beast.
Yeah. I've not really played with much CI/CD, but it'd be really, really good to get into it. But yeah, certainly I feel the frustration if you've maybe been developing an application and you think, oh, I put a couple of new features in and I'll do a build now for testing or whatever, and you realize that your build is broken for some reason. Maybe you've got some weird circular dependency, or like a Vim just isn't happy.
Yeah.
And so like it'd be getting that fast feedback like as you're making those changes and commits to sort of more towards a feature, you can at least see like, oh yeah, okay, I thought that would build, but it doesn't. So that would getting those signals earlier would be handy.
Well, I'm working with a team right now, and they have this project, and it takes like 3 hours to build, but they haven't been building it and testing it all along. So it builds, but it doesn't run.
Mm-hmm.
It runs, but it crashes because it's actor framework, and they're launching stuff dynamically, which makes it even harder to debug because you can attach a debugger, but you see the launcher, and then everything else is hidden, and you got to figure out how to get to that. But that's one where I think if they had been doing it all along, they would note it because it has something to do with, I haven't figured out the entire problem yet, but something to do with not including some dependencies. And if you're testing it all along, you would realize like, hey, the last build broke. Okay, which actor did we add? Okay, that's the one that's causing the problem. But they're at the point where they got like 300 actors, and it's like, okay, well, which one's not loading correctly? We don't know. How do we
Yeah,
figure
yeah,
that out? Yeah.
yeah. And in a way, I guess you just have to start rebuilding the application from piece by piece and seeing at what point it breaks. But I think for certainly times I've had like one executable builds and another executable builds, but when I put those two bits of code together, they don't build, and it doesn't
Yeah.
make any sense. I think some of these were issues I had with an application that was I'm really trying to dive into using interfaces to define different architectures and stuff and like behaviors. And LabVIEW 2020 is kind of when those came in, and it does a really good job. But certain times, I think the application builder sort of misses some dependencies and then like starts eliminating code that is required, and the build will just break. But it'll break on what was the last error I had? Something about like an actor framework init queue, like something that I'm not touching and should be there is like all of a sudden broken. So in those cases, upgrading to LabVIEW 2023 seemed to fix most of it. But then you're like going from a sort of a LabVIEW distribution, a LabVIEW version that you're kind of quite familiar with, and you like the driver set and stuff, and it's good for if certain customers haven't moved on to newer versions, then 2020 is kind of a nice point to start. It's got interfaces and picked up maps and sets from the previous year and stuff, so it's quite a good version to standardize on. So you move to a newer version to get stuff building, but then are you going to have things that aren't going to work anymore, or do you have to retest all your toolkits and drivers and everything else that you maybe missed in a change notes, like, oh, this isn't supported anymore, and something stops working on RT, all those things that can happen when you choose to go to a big version, make a big version jump.
Yeah, I think NI is missing something there in the sense that, like, I think if they were to introduce an LTS version, I think a lot of people would be very happy with them, because I feel like their solution to every problem is, oh, just upgrade to the latest version, and that's easy until, like you said, you have incompatibility issues with hardware and other reasons, and there are reasons that you can't upgrade. But if they had an LTS version where they backported some of those bug fixes, that would be quite nice. Because right now, my understanding is bug fixes don't really get backported at all. Like once it's out the door and they have a new version, the old version, unless it's like a security issue, they're not touching it.
Yeah, you just have to hope that a very valuable customer of theirs has the same issue, and they can put some resource behind backporting whatever fix they get into it. But it's not it's not always doable, and they might just choose to fix the reason why that valuable customer can't move to a newer version to get everything else. But
and work around or something. Yeah, I worked at a customer once where we got our own special build of Linux RT because we found some kind of bug, and we were, I guess, at that point special enough that they made a special build just for us. But I don't think they released that to everybody else. So
just blessed in that occasion, I guess.
Yeah. I mean, there are definitely reasons for that. So one of the things I wanted to talk about is you came from academia until recently, right? And you just recently started an alliance partner. What's that shift like?
Yeah, I mean, there's like the day to day is quite different. So in academia, I was in a group that was looking at robotics around like nuclear decommissioning. And I don't know how it was, I don't know, 10 years ago, but these days it's like the default is ROS, the robotics operating system, which is like Linux based, all open source. So me being there in that group as a LabVIEW developer was always a bit odd. I was very much the odd one out. I'm aware that there were sort of other people maybe using NI hardware sort of more broadly within the School of Electrical and Electronic Engineering, but in the field of robotics, it was like just no one would touch it because it was probably running on Windows and all the licensing and other stuff around it.
I'm guessing ROS is not one of the supported distributions for Linux, because like NI does support like Ubuntu and Red Hat and maybe CentOS or something.
Well, it's called the robotics operating system, but it's essentially just an application that runs within on they tie it to like a particular distribution of Ubuntu. So if you have like Ubuntu 17 point whatever it was, you use like Melodic. and they, and then as you change version, so that's one of the things where even though it's an open source project, they do that long term stability thing, because they're trying to get it used in industry and all sorts of stuff. So yeah, so it's just ubiquitous in the field, and there's so many tools that you wouldn't choose to use anything else. So yeah, so being a LabVIEW developer was always like just sort of missing the chance to chat with people about LabVIEW. There's always like the small bits where you're like, oh, I'm thinking of doing this, and what are your thoughts on this architecture? So you could kind of chat to people more generally, like how would you structure these applications? Because ROS is like, certainly in ROS 1, it provides like a messaging layer, so everything's sort of running as separate little processes, and it's all primarily publisher and subscribe based messaging. And like everything's defined by configuration files. So you could still sort of chat to people in the more generic sense of like, oh, I've got this bit of hardware and I think I might sort of bundle that off in its own module and it can speak this way or whatever. But yeah, you couldn't be like, do you think I should use a DVR here, or would this work? So I did miss having those that option so close. I mean, I can always ask on forums or whatever, but it's not quite the same. It's just having someone across the way on your desk that you can just have a quick discussion about stuff with. I guess the other thing with working an alliance partner is just the rate of sort of projects coming through. The project I was working on in the university, or a number of projects, were like sort of around 3 years in duration. Yeah, it's quite different to maybe more system integrator, alliance partner type work, where you're trying to you've often got things that are coming through sort of 6 weeks, couple of months to try and get things moving along, and then you're balancing that with other projects that are ramping up or tailing off, and some support for customers. So it's quite different in terms of things are always changing. The other difference is just from an organizational front. So universities are like big organizations with lots of different layers and processes and things in place. But certainly the alliance partner I work for, Control Software Solutions, we're nowhere near the size of a university. So I'm much more involved in different aspects of the business, which is really interesting to add that to the side of just sitting and coding or whatever. So yeah, it's also quite fun to sort of join. When I'm doing like commissioning on a project, I kind of get to like join a team for a week or whatever in a different company and see how they work. And sort of that's quite fun, just to encounter all these different projects and interesting things that people are doing in the world of like science and engineering at a much quicker rate than I would necessarily like focus on an academic project. Also, generally the outputs are a bit different. In academia, you're generally looking to deliver like research papers and like intellectual property, instead of like a system that reliably works and can test hundreds or whatever thousands of units a day and just keeps on plugging away. So it's quite a different just a different approach to developing software and managing your time and projects.
I'm curious how that affects software quality, because I'm thinking like, in general, I have a very low opinion of the quality in universities. But when I think about it that way, though, like if you're working on a project for 3 years, there's an incentive to think about project quality, right? Because Fabiola says, "Be kind to future you." So there's more future you versus if you're doing a 6-week project where you're turning it over to this other company at the end. There's kind of less incentive to think about future proofing stuff and more incentive to just get it out the door.
Yeah, I think you certainly have to, if you're like doing something really research based, it's all unknowns. So you have to try and you choose an architecture that can be quite flexible, because you never know, you're gonna have to like swap out a part, like, or like a module or whatever, some bit of hardware that you spent lots of your grant money on doesn't actually work in the way that you need it to. So you have to like borrow something else, but it has an entirely different interface or something like that. So if you can be thoughtful in how you construct things, you can mitigate those sort of challenges you might face. I think on the whole, like if the output of your research is you want good solid data, but you are going to be the only user of your software, you don't necessarily care that you've like declared absolute paths, because your C folder is always going to have the structure that it has, right? There's sort of just little quality things like that. You never have to worry about distribution, really, or like documentation. I mean, you'll not thank yourself in 6 months when you have to like rerun some code and it breaks. But if you're if you're just looking at doing some process or getting some data and then processing it and publishing it, then the reliability of the code and maintainability is not necessarily your first focus. I mean, I had previously worked at a particle accelerator, so that very much was our focus then when I was doing beam instrumentation, data acquisition around that. We want something reliable. The particle accelerator would operate for 24 hours a day in 30 plus day long runs. So any unscheduled maintenance was like serious in terms of it would affect the whole accelerator, and the accelerator was used to produce neutrons that material scientists were like coming to do studies with. So it was like a user facility. So you'd be affecting other people's research and science if a bit of your equipment broke and stopped the whole accelerator working. So I certainly had that experience of like, I like it when code is reliable. I like it when it's maintainable and all that good stuff. And I know that I appreciate the effort I made earlier on in the project to sort of sketch things out and make things flexible and maintainable. Then later down the line, when I encountered issues, I sort of knew that the bits of code like that I tested were good and worked, and I could like it just made it. Yeah, I mean, it's just like all these things, right? It makes it quicker to debug whatever situation you're in if you've been able to build code in a modular way. And so
yeah, I feel like one of the things that we do poorly in LabVIEW is testing and refactoring. I feel like we try to do this, like design it perfect up front first, and then of course it's never perfect, and then when we have to make changes later, it's a lot harder than it needs to be.
yeah, I mean, it's amazing how many times you have to kind of learn that lesson until you think, well, requirements are going to change, um, and yeah. I mean, I think I've seen you discussing this before, and maybe on the LabVIEW Discord and stuff, that LabVIEW is lacking those tools that make refactoring easy. I don't know about anyone else, but certainly you think, oh, I can just change the name of this VI, and then and you forget that you haven't got something open, and then it's just one VI, and then. Or if you make the mistake of changing the name of a library, then it's it's miserable. Like you kind of get punished by the IDE whenever you try and make those changes. Yeah, I mean so I guess that's it. Like there's a higher cost of making those changes. So you think, well, I'm just going to have to get it right first time, and let's hope I never have to change those big things and suffer that pain.
Yeah, I think the trick is figuring out, and maybe we need a list of this somewhere on the LabVIEW wiki or something, Q, if you're listening. But like, what things are easy to change in LabVIEW and what things are hard, right? Because the things that are hard to change, those are the things that you want to be a little bit more careful and circumspect about up front. But the things that are easy to change, in that case, like, why not just push those decisions off until you have more information?
Yeah, absolutely. I don't know how you find it with like if you've got multiple developers working on a project, you want to kind of define some interfaces, or like I'm not necessarily saying classes, but you define the edges of the different modules that you're building. And in a way, then there's an extra bit of friction, like because if I change this, then in a major way, then I'm sort of affecting all the code throughout the whole project, and am I then going to be like a blocker for my colleagues? Because I'm like, you're just going to have to let me. I'm going to pull down all the changes, apply my changes, and then like I'm just going to spend a whole morning putting everything back in place, and then you can all push and resume. But I'm certainly you certainly feel that you're blocking their development and stuff.
Those modular interfaces, I think, are a good place to try to put a little extra effort up front. But also, I feel like depending on if you do them correctly, you can make them flexible in ways that you can extend. So like making them, class-based instead of clusters or something is probably useful. because then you can do overrides if you have to, or things like that that won't break existing code as much.
Yeah, yeah,
So
absolutely. I think, I'm so glad that classes are really sort of really there in LabVIEW and yeah, just provide that flexibility that you need for stuff. And also like more NI provided tools and things, and community tools are sort of using classes. I think the as a community we've decided like we've had I don't know 10 years or more of classes. We can sort of like it used to be perceived that they had this big learning curve, and if you were trying to make maybe like a reuse library, you might try and avoid them. Whereas that's the thing that they're really good at is those sort of encapsulating code
yeah,
behavior and all sorts of other things. So it was a shame that we weren't, but I think now we're sort of accepting that we can start using classes, and people who aren't sure can just sort of the community can help bring everyone up to that level and demonstrate the value to
yeah.
everyone of using those things. So I'm glad that it feels like we're moving in the right direction. I mean, there's still a lot to learn, I think, for everyone. And like if you're in like other languages make use of classes in different ways. Some like really focus on like the sort of Java world, very like rigid hierarchy, but they provide lots of functionality to sort of have multiple inheritance and other things going on. And with LabVIEW, we've got kind of one model for how classes work. With the addition of interfaces, it really helped broaden that out, which was great. But yeah, you've got to sort of like feel how the thing that you want to implement with LabVIEW classes has to be done in that LabVIEW way, instead of maybe like just borrowing something wholesale from a different language. I'm certainly trying to write much smaller classes than I used to, and use like composition and stuff instead of just going, this device shall operate in exactly this way, and and then finding that the next device I look at doesn't, and then you're like, I've made some terrible assumptions on how this is going to work. But those are things that you ideally do, in a little quick iteration cycle as a little test before you build your whole architecture around those sort of assumptions. So.
Yeah, I think with classes, one of the things is learning about the various design patterns and not like reinventing the wheel. Tom and I had put together some examples somewhere. But like I found a good use case for interfaces and design patterns the other day. So this company I was working with, they had two systems and they both had motor drivers. They're two different motors, but they both inherited from a different set of classes. Right? So
Mm-hmm.
the inheritance is different. And they wanted to be able to use this one motor over here, but like because of the inheritance problem, and they were like, oh, we can just rewrite the driver over here to match this. And I was like, instead of doing that, let's like, create an interface and make an adapter class and just that little design pattern saved them from having to rewrite everything, which I think, and made it way more flexible. So, but I think part of it is just knowing they exist and knowing how to apply them.
Yeah, I think that's it. Is not really being from a computer science background. I sort of the way I really encountered classes was like as a hardware abstraction layer is like they're like classic LabVIEW. I mean, once you've gone past like a car, and a vehicle and it's a bicycle and all that stuff, like that makes no sense. I don't know why we bother with that stuff. Like hardware abstraction layers, and then that kind of that makes you think of classes in a certain way, like just with like this inheritance tree, and it's only then maybe as you look at more design patterns, and especially when people have helpfully in the community sort of done like, this is how you could do this in LabVIEW. You're like, oh, okay, like the state pattern and other sort of things. Mm-hmm. That makes you just it just really broadens out your range of tools that you have. And I think it's why for me classes are so invaluable because I've just like they solve so many problems that I would otherwise have to work my way around in quite convoluted ways. So
they give you a lot of flexibility.
Yeah, and then what we've been trying as a company is looking at model view presenter type architectures for when it comes to like your GUI and your presentation logic, sort of how you can separate those using this pattern. And I've I've previously really struggled when it comes to doing like quite trying to make like quite intuitive and interactive user interfaces. So you end up with like lots of property nodes, and you realize that it's quite easy to get your like your display code coupled in with some of your general application code. So following this pattern and defining like user interface stuff through an interface class, and then providing a concrete implementation that actually does the like property node calls really helps separate that for me. And it also means that when I want to test like a bit of application logic, I can sort of just run that application logic devoid of actual UI. It's like you can sort of mock out the UI in a way that LabVIEW sort of has made it more difficult, just in how the UI is generally somewhat coupled to the application as a whole. So that approach has really really made me feel a bit happier about some of the UI stuff that LabVIEW sort of forces you into. I mean, I still wish that the enum for disabled and grayed was smaller, but I know I'm going to have to put that inside a VI, so it's not so bad anymore as when I think, I can just drop that on the block diagram and it'll. But anyway, this is just the weird bugbears of LabVIEW code.
Yeah, well, I started studying a little bit of functional programming lately, and one of the things that they talk about, which is probably related to this, is like separating out all the side effects from the actual logic, so that all your functions then become what in functional programming is called a pure function. But basically, like a pure function is like I have a set of inputs, they go into the function, and the only thing the function does is calculate the output. It's not writing to a serial port or a file or doing any kind of GUI stuff. There's no interaction. And those type of functions are incredibly easy to test. Mm-hmm. And so like pulling out, like if you've got something that communicates with the serial device, all the logic that formats the command to send, if you could put that in a separate sub-VI, then you can easily test that. And then, then you have to trust that once you send it over the serial port, it actually arrives on the other side the way you want and all that. And that's probably more of like an integration test, but you can test that logic, and then you can change that logic and be sure that you're still getting the same output. So that's really useful tactic.
Yeah, and I found it handy, that sort of thing, when you're maybe creating an abstraction layer because you want to have like simulated devices, having a couple of points where you can like essentially create simulated devices is quite handy. So you can just mimic like the really low level bit of like the serial transport, or you can like I had one device that's just like a sort of a big memory map that just addresses and you're just reading bytes from. So just to sort of be able to mimic just like essentially the memory array and then be able to manipulate it that way and see how that works with the rest of the application is really handy. So yeah, certainly like breaking your code out that way has like other additional benefits that you maybe don't see when you first just think about doing it. So would recommend.
Yeah, Enrique put me onto this interesting program called COM0COM that emulates COM ports. And you can create virtual loopbacks. So you can have like your code that talks to some instrument, and you can just set it to a loopback, and then you can either like inspect what it's sending, or you could like write your own simulator to then send stuff back and make sure that you're getting the right data back and processing it correctly. Yeah. So that's a really cool technique.
Oh, that sounds really cool. Yeah, I can certainly see uses for that. Quite a few.
Yeah, that's cool.
Did you know that the LabVIEW Experiment has a Patreon? All memberships include access to a private Discord server where you'll be able to chat with other fans. Benefits to membership include behind-the-scenes content and sneak peeks at new episodes, as well as opportunities to chat and even code with Sam. To learn more, check out our website, www.thelabviewexperiment.com. It's your contributions that keep our experiment going. Thanks.
The other thing I've been working on a lot lately is something called approval testing, which is pretty cool, where like I use it for a serial port thing where I did the loopback, and then I just captured what was on the loopback and just saved it to a text file, and then I could run it again and then compare and make sure that the same stuff was coming out. And that's pretty useful.
Yeah. Because I think so. At the moment, I'm creating an open source library that does a bit of image manipulation. So for like some basic image functions, you can kind of construct your expected result like sort of dynamically, like you. But for other things, you're like, I really just have to sort of give a defined input and then capture the output and then store that. So as you say, you know when it's changed, something's gone wrong, but you're sort of capturing that the behavior for this particular input works, and that probably from that you can infer that more broadly the function works, or that something has or hasn't changed in your implementation underneath the hood. So yeah, that would be a good approach, I think, to try there.
Yeah, we should definitely talk more about that. I did an interview for Software Engineering Radio with Llewellyn Falco. I don't know if you listened to that or not, but if you haven't, you should go listen to it, because we talk about approval testing, and he was using it for images. Because like the classic one with images is like, okay, I've got this thing that does X, whatever it does to your image, and you're trying to find the smallest image that you can do, like the 9x9 grid that does exactly what you want to do, and it does it on that one little thing, and that's your test. But like trying to create that example is such a pain in the butt. But if you have a picture and you can say, okay, run this picture through that algorithm, and I know what it should look like on the other side, then it's a lot easier to and you can run the approval test with like some image diff tools and stuff that like, you run it, and if it's different, it pops up and it shows you where it's different, and then you can go investigate. And it's just like it seems like a more intuitive style of testing than trying to create this like image that like, 9 pixels by 9 pixels, but looks exactly the way you want. It's just,
Yeah, that sounds really good.
Yeah, that's cool. So I have a couple other questions. One question was just like going from academia into Alliance Pro. Like, what was the onboarding process like, and how did that go? And like, do you have any advice on like how to onboard new people in organizations?
I think for me it was quite smooth because in terms of the sort of work that we were doing when I was starting, I was sort of just given quite small projects. So the onboarding for me was just getting up to speed with like the Azure DevOps type tools that we use. So sort of learning those things took a little while, but that's sort of best done by like essentially doing things. You understand the flow, and we have some sort of internal documentation about the processes that we use that I could go through. So that was didn't I found that quite straightforward. I guess it helps that I wasn't necessarily I wasn't trying to learn like a new technology stack at the same time. We use lots of classes, and I had lots of experience with class-based architectures and sort of all sorts of stuff in the past. And then the projects I sort of started working on were quite R&D, and I'm sort of used to like that sort of working in that world. So that was quite straightforward, and it gave me the space to like learn the other things about the organization that I needed to, without having to get overloaded by trying to learn everything or having to learn everything at the same time. But recently, as a company, we've been looking at expanding, and we have taken on an apprentice. So in the UK, an apprentice is generally someone who maybe would have gone to university, but they sort of chose a more like vocational path, or they wanted a route that involved like learning and like on the job sort of work and training. So we've recently done that, and it's been interesting. Reassessing like the tools available to us to like for people to learn LabVIEW again. And I'm just going to give Tom McQuillan's a Udemy course a good plug, because our apprentices really enjoyed going through that material. And then I think that the challenge for an organization is trying to provide being able to provide the support that person needs to get up to speed, whilst also trying to manage all the other sort of work that you have going on. So it's definitely a balancing act, and we're kind of building our skills at doing it, but it's going all right so far. But yeah, we have sort of a number of internal resources that like explain how we use DevOps, and a number of reuse libraries and how they work and stuff. So we have that stuff was already written down, which makes life a bit easier. But you have to keep it up to date as things change. So there's still that like maintenance side of things that has to be done. So it wasn't that transition for me was easy, and bringing other people on board has also been okay. And there's learning that we need to do, and yeah, things that we're keen to develop. And yeah, especially because, so one of the reasons that we took on this apprentice is that we're interested in maybe broadening out some of the things that we build, so integrating maybe more C# or other type applications or other type sort of languages and things, and make these like hybrid applications that are a bit more well, not being as dependent on LabVIEW is good, broadening the type of solutions we can deliver. And also we generally find, like, as user interface experiences in the broader world on smartphones and whatever tablets has it keeps getting more and more interactive, more and more like intuitive in theory to use. Like, trying to replicate some of those with LabVIEW really takes a lot of effort. So, is there something to be gained by having more of the UI stuff done in like a C# application? Maybe it can run in an application or in a browser or something, and then having more of the test and measurement side of things done just with the LabVIEW in a sort of headless form. So so taking on an apprentice who could then also, whilst learning LabVIEW, also do some more development in C#, and we can give them some projects to sort of be getting on to do some like proof of concepts and stuff. So we're hoping that kind of works quite well, with also giving that apprentice exposure to not just LabVIEW and other languages as they develop and grow as a software developer. So that's the ambition.
Yeah, I found that interesting. Like, switching to C# because it has better GUI is interesting, because I always thought one of the selling points of LabVIEW was that you kind of get the GUI for free. Right? When you create a sub VI, you instantly have a GUI there. But I do hear lots of people complaining about some of the limitations of the LabVIEW GUI experience.
Yeah, I mean, I definitely appreciate each sub VI having a GUI when you're like doing like more experimental stuff, or for some debugging it can be really handy. But I'm starting to really get tired of like doing splitters and subpanels and panels and subsplitters.
Yeah.
And then someone says, oh, we want to be able to do this at two different screen resolutions. Then you sort of get something looking nice for one, and then it doesn't maybe scale as nicely as you want on the other. Or you find that some controls will scale nicely, others do something weird, like the LabVIEW table, the multi-column list box. When you sort of, if you stretch it, it doesn't like grow the columns, it just adds more columns on the side, and you're like, that's not what I want. So then you have to try and listen for events and shuffle stuff around, like listen for resize events, and so that can be a real challenge. Whereas other applications sort of give you more of that dynamic stuff for free. I mean, that's if you create things for the web, you don't, once you've got your sort of your hierarchy of components and how they'll all resize and flow happening, you get a responsive application quite nicely for different resolutions. Or like, if you all of a sudden you need to add an extra 10 test steps, and you want like an indicator for them to have passed in LabVIEW, that's like quite a bit of effort. Are you going to add like a scroll bar and then scroll clusters and stuff? Whereas if it's just a web page type thing or a similar container for your content, then it just happens more flexibly out of the box. So that's one of the things that we're interested in investigating.
Very cool. There was one other thing I wanted to ask about when it comes to other languages. You mentioned that you've tried Rust. What was your experience with that?
I think that so I've had a couple of run-ups at it. I think I get to the point where I'm like, oh, I could do something useful with this, but I can't quite find a project or a thing that would be like enough challenge, but not too much, to really get into using it. So I've gone through the Rust book, I guess like sort of some of the way a couple of times, and tried other resources, and it's like I have found it's made me better at C++ programming, because I now understand more of like what C++ is doing and how I'm managing pointers and type things, and the assumptions I'm making as to like who owns what, which is the very Rust way of playing. Like you own this thing in memory, and this is how long it will exist in memory, and if someone else needs to mutate it, then they now own it and you don't own it. So you get all that control with Rust. But yeah, I think the challenge is that I'm usually sort of keen to build something with it maybe a bit too soon, or I'm like, well, I could kind of do this in LabVIEW this way, or I suppose I'm 90% of the way there with doing it in C++. I could learn a bit of that, but it's certainly a language that I would love to, find that appropriate thing to work on and have a good chance to dive in. It's and I think it's made me think more about like composition. So Rust doesn't have objects in the way that other OOP based languages do. But they have this concept around enums and so there's I've not looked at it for a year now, so it's kind of all gone a bit hazy. But yeah, it was I wouldn't choose to learn C++ now. I'd start with Rust, I think. But it's kind of C++ is some of the knowledge that I have, and I'm just kind of trying to bring stuff into LabVIEW generally with that. I'm building C++ to bring it into LabVIEW. So trying to integrate Rust into that process is a bit different. I know that James McNally has a Rust LabVIEW interop library that he is working on, has made quite a bit of progress on. But it's on my long list of must check this out at some point and dive into it. So yeah, and then the other language that I really feel like I should get into but haven't is Python. When I was my language journey has sort of been C and a bit of Java at university, and then LabVIEW, and then I've sort of picked up more C++ to sort of complement the C, and then I also did quite a bit of JavaScript. And that sort of web stuff. So that was good. And then I kind of never really got on the boat with Python when it was all kicking off. So now I kind of have a scripting language with JavaScript. I'm like, well, that's kind of it. Python is kind of ubiquitous, but JavaScript, everyone has a JavaScript interpreter in their browser. So it's even more everywhere. So yeah, but yeah, and I'm still not sure how I feel about white space meaning stuff, but at some point I will dive more into Python. Yeah,
That's cool. Yeah, I've been doing some Python. I've looked at Rust. I've tried it. I don't know. It just writing it seems rather tedious and it seems difficult to read. But maybe that's just me. Maybe I just need more practice.
I think it's quite a common criticism is that it's very verbose in how you express things, and that also means that you've just got to hold lots of things in your head when you're reading it and comprehending what's going on. And I think until you have that almost as a muscle memory that you just sort of you're not really reading the syntax, you just sort of intuit that means this is being borrowed and this is being moved and whatever that just sort of. Yeah, until you've got that in your head, it's just what does that mean? Why is there an arrow there? What's going on? Yeah.
Well, the other thing, Python reads very easily because it very much reads like English language, very much reads like pseudocode, and so that makes it a little bit easier. But the other thing I like about Python is in Python, there's generally one best way to do things, and in Rust, my understanding is there's lots of different ways to do things. It's up to you to pick which one you want, and it's the overwhelming choice. It's kind of like the problem if you've used test stand at all. Test stand lets you do all kinds of things in different ways, and so trying to figure out a standard way of doing things is really difficult.
Yeah. I agree. One of the challenges I have with Rust is just when you're I'm not quite sure how to do this, and you Google stuff and you go, okay, there's so many ways. Should I know all of these? Do I? I don't understand which is the best approach for me at this time. So yeah, I think that's one of the difficulties. But I mean, C++ is no better, right? I do so much Stack Overflow and other Googling when I'm trying to write any C++ code. I assume that it's going to translate to Rust as well. So I mean, one of the challenges is maybe just I'm so familiar with LabVIEW. It's very difficult not to just want to choose that as the default, because then I can more focus on the thing I'm trying to do instead of just the tools that I'm using to get there. So that's the other thing is trying to have the focus and discipline to go like accept that you're going slower doing this thing in a language you're not as familiar with. Um, yeah, I kind of liken it. I recently or swapped to using like a graphics tablet when I'm programming LabVIEW instead of a mouse because I was having, I was finding my sort of getting wrist strain after a certain while. And some of it's just, I should take more breaks, but you're sort of, you're in the zone, you're focused. And then, at the end of the day, you find you're sort of, a bit sore of wrist. But it was like a really frustrating week or week and a half, or maybe even 2 weeks of like feeling like I was going much slower trying to use this drawing tablet to, manipulate the IDE. Love you, IDE. But now I really enjoy it, and I find it just much more comfortable, and it prevents me getting the wrist strain that I was starting to get. So yeah, I think that's just it. You just have to accept that it's going to be a bit rough but then, it gets easier.
Well, yeah, that's like the whole learning curve. Everybody forgets, like they think that you just jump from point A to point B and you suddenly learn something new and you're more proficient. And the reality is you become less proficient until you get back to where you were. So, and then hopefully it keeps going up after that, and then you're good. But you gotta account for that. I do have a couple questions around open source stuff. So you've been working on some augmented reality stuff in LabVIEW. You want to talk about that a little bit?
Yeah, so one of the projects I was building whilst I was at the University of Manchester was involved using a camera to track essentially an inspection tool being moved around inside a big chemical reactor. So the idea is we had this webcam that was sort of focused on above in the area looking down, and then we'd have a number of easy to spot like QR type codes on various objects that were moving, and we were trying to keep track of where all the objects were, with the idea being that we could then like provide for the operators a map of where they've been with the survey tool, just to make their life easier, because if not, it's a big cylindrical space, so you easily lose track of exactly where you've been and where you haven't, and you can sort of mark stuff with like chalk or whatever, but it's it's a challenge. So I started with that project, and I sort of, when I finished at university, I was like, well, I kind of have all this knowledge now on like these camera systems and pulling out markers and images, and then trying to interpret that information to build like a 3D map of a space. And I thought it would kind of be cool to like release that as a community tool in some way. I mean, it might be no use, but you can do like the kind of quite fun like augmented reality experiences, like essentially like Pokemon Go from about 5 years ago, where you can just sort of make some sort of sprite float in space, and as you move your camera, the sprite moves, or like it sort of moves with the world. And when I was like doing this, I thought, well, no one really cares about augmented reality anymore. It was kind of like the big fad thing in 2015. I think it was either like around that time there was an NI week where they even had like a demo where someone had I think they had like a mountain bike, and they had they like held up an iPad and it would tell you like how quick the wheel was spinning or something, and it was using augmented reality to do that. But not crisply, not in LabVIEW, just using some bit of NI hardware. So I thought, well, it'd be kind of fun to do that. I also was keen to provide an open source alternative to lots of the iMac and like iMac DX stuff. So, it's a real shame that if you want to kind of use your webcam in LabVIEW, you probably maybe need to, you might need a license to run the iMac DX stuff, or you have to do something, I don't know, maybe use some Python. So I was keen to like bring a kind of up-to-date modern webcam driver for LabVIEW, so I could bring that into my toolkit for my augmented reality. And then also like a bit of image processing stuff, which would also replace some of the iMac type tools, like beyond the basic, I guess it's like you're verging on the vision stuff. Even though I sort of spent a year and a half using these NI tools, I still can't exactly tell you which bit's like iMac, which bit's NI Vision, which bit's iMac DX. So it's all, like that was part of the thing. I thought like it would be great if there was an open source option that meant you didn't have to play this game and work out, do I need a deployment license for this? And is it like cross-platform and stuff? So I sort of had the knowledge. I'd already been able to integrate it into LabVIEW once. I thought it'd be good to sort of take what I'd learned and then produce a community package. I mean, this it was perhaps I was perhaps over ambitious, but it's coming together. One of the big hurdles was trying to find a nice way of using the more modern Windows webcam drivers, which is the Windows Media Foundation, might be framework. Yeah, so like trying to bring that into LabVIEW was a real pain, but I've now sort of got that cracked. So I now get to just do the more fun parts of like, yeah, getting to the bits that actually are augmented reality, detecting markers in the real world and drawing little sprites. But I've had to do quite a bit of work around that to make that happen. But yeah, that library is coming together, and it is. I do have it on GitLab, so you can sort of follow the work in progress. But it's very much a work in progress. I wouldn't, you might be keen to use your webcam in LabVIEW, but I wouldn't advise using this toolkit just yet. I'll get around to a release at some point. But yeah, that's been a lot of fun, and it would be nice just to sort of get it out of my head and into the world. Yeah. So yeah.
Yeah, I like working on open source projects. It's freeing, right? Because like you're doing it for you, so like you're in charge. You get to set your own kind of standards and style, and you're not really constrained by anything. But
yeah, and when I've done previous open source packages and things, I've been like, oh, I want to make it. I want to think about how useful it's going to be for everyone, and it's sort of freeing in a way to be like, I just kind of want this thing to exist, and if other people use it, that'd be great. And you can also get a bit of community feedback. It's not like you're trying to make a proprietary thing that you maybe can't necessarily share in the way that you'd want. You can be like, look, I'm building this thing, and if people have opinions, they can chip in, but it's my thing. If you want to build it a different way, you can take the code and go and do your own thing. It's it's kind of nice. You've got the flexibility, as you say, to build it as you want, but as part of a community, if you so wish.
Yeah, I find I have two different types of open source projects. Like one is just like I made this thing and I don't care if anybody else uses it. I'm just throwing it out there in case somebody finds it useful. And then there's that I'm building a tool that I intentionally want other people to use, and then it's a little more restrictive at that point, because then you're more worried about breaking stuff and you're more worried about polishing it and making sure it's documented well. And so there's a little bit of that. Yeah. Cool. All right. The last thing I like to do is ask a question, which is tell me about an experiment that you tried that did not turn out the way you thought it would, and what did you learn?
I guess this is going back to the augmented reality thing. So when I started this project, the assumption was that we could use the camera looking down on the surface, and we could model everything in 2 dimensions. So it's kind of quite easy. You've got a 2D image, and maybe you do a little calibration where you work out how many pixels relates to a certain distance. But then once you've got that, you'd be like, well, there's a thing over there, and I know it's like X pixels from the center, so that must be X meters from the center. So that I sort of tried building a system that worked like this, or used this approach, and it just sort of it never quite worked. And I'd be like, oh, maybe I'll just try recalibrating, and I'll just try doing this. And then in the end, I sort of had to take a step back and look at, go like this model of the world is 2D just isn't the case, right? So that's then when I had to do a bit of a deep dive on understanding more of like how you can model this stuff in 3D, sort of go forward then. And that's then when I came into all this augmented reality type stuff. But before then, I would have just been trying to like draw pixels on a 2D image and hoping for the best. So it's only by accepting like that wasn't working, the model didn't sufficiently represent the real world, and then taking a step back, that I was able to get where I needed to be, and also like learn all this new stuff that was really, really fun and interesting to be working on. So that's I guess that's probably an example.
So did you go back to did you end up using 2 cameras then to get like stereoscopic imagery, or?
You can get away with 1 camera, but you're relying on the markers that are using these like QR type marker things. You're more reliant on knowing exactly the sort of size of them, and then from that you can sort of infer how they're positioned, and that's like maybe if you orientate your world around like a certain pattern of markers or something, you can then sort of build a 3D world. But it's all very relative to like 1 camera. So yeah, you can use stereoscopic vision. stuff. But in this case, it was just a single webcam setup and a whole load of maths, which luckily I didn't have to do someone already written. So that was a big win.
Very cool. All right. Well, that sounds like an interesting lesson. So it's been great talking to you. People want to get a hold of you, they can find you on any of the various forums, I'm sure, right?
Yeah. Just I used to be on Twitter, but that became a lot less fun. So I'm on the Discord, the LabVIEW Discord. You can find me quite easily, or I have a GitHub and I have a GitLab, which they're not too hard to find. I'll send you some links you can put in the show notes, maybe. Yeah, great, thanks.
All right, thank you.
Cheers.
Awesome. That's it for today's episode of the LabVIEW Experiment. Thanks for listening. If you have any comments or questions, head over to thelabviewexperiment.com and drop me a note. And don't forget to subscribe to the podcast and follow us on Twitter and Instagram @TheLVExperiment.